Spire is actually quite powerful when it comes to this kind of thing, using two rail sweeps, being able to use a shape creation, using our sheets feature.
Hello and welcome back to the 2023 Vectric user group meeting. Now in this video I'm going to show you how to create this side table on your CNC. So as you can see, we've machined many sides of material to create this table, and this is what we call a multi-sided project. So let's talk a little bit about that. What is a multi-sided project? So a multi-sided project is anything that has more than one face. We've got lots of different ways that you can create multi-sided parts in the software. For example, you can create a series of single-sided parts, assemble them together to create a multi-sided part, just like this box. We have the ability to create two-sided parts in our software, where you machine on the top side and the bottom side to create a two-sided part. We have the ability to machine on a rotary, where you can machine all around a part. So creating multi-sided parts really opens up the opportunity for some more useful projects, for example, furniture, toys, gifts, household items. And so in this video, we're going to explore how we created this side table that consists both of two- and four-sided machining. So two-sided machining for the tabletop, where we have a molded border around the outside. Underneath we've got pockets for our legs to be inserted into. Then we've got four legs, and each one of these legs has four sides that have been machined, so we're doing four-sided machining. And so we're going to look at how we designed this in the software, and we're going to look at how we can effectively and accurately create a really good hold down and ensure that every time we flip our material, we have everything accurately aligned in terms of their X and Y locations. So we're going to jump into the software and we'll take a look at how we do this. So let's just take a moment to discuss how we created this project. So there are two main elements to this table. There are the four legs that will be machined on all four sides, and a tabletop that will be machined in a two-sided operation. So let's talk about the legs to begin with. Now the way that we're going to approach this is by creating four blanks that are the same width and height to ensure that we have perfectly square blanks from the get-go. And the idea is that we'll make a jig that we can slot our leg in to machine each side. So how do we ensure that we're going to secure the part down and that our X0 and Y0 will marry up correctly on each face that we cut? Well, it's actually quite simple. Let's have a look at how we do that. Okay, so we're going to start with our blank. So our blank is going to be the same width and height as each other to ensure we have a nice square blank. And then we've got the length set at whatever you want it to be. So the next thing you need to do is you need to create a new sheet. And in that sheet, we're going to set that up exactly the same size as one of our blanks. And then we're going to create a rectangle that is the full size of our sheet. We've got fillets in there to ensure that we can cut in at the corners. And we're going to set our X0, Y0 from the lower left hand corner. And this is going to be our jig, and we're going to cut down as far as we want to. So in this case, I'm actually going to cut down half of the thickness of our blank to ensure that we have half of it secured into our pocket and then half of it will be exposed. And so the idea is we take our piece of material that we want to cut our jig into, set our X0, Y0 to wherever we want it to be, and then we're going to cut that jig or that pocket. So it's going to look something like this. And so by having half of the thickness of the actual blank, it's going to give us a nice hold in there. It's worth noting that when we cut this pocket, we're not having any form of allowance. It's going to be the exact same width and height as our blank, and that's going to ensure we're going to have a very, very snug fit. We're going to be using a mallet to put our blanks in to ensure that we have a nice tight fit. It's not going to move anywhere. And then once we put our blank in, it's going to look something like this, okay? So there's our blank sat within our jig. So the first thing we need to do is set our Z0 off of the blank top surface. We don't need to change our X0, Y0, that will remain the same as we're referencing everything from the corner of our jig. And then the idea is we'll machine the toolpaths for this side, so it will look something like this. And once we've done that, we then take the part out and then we rotate it 90 degrees to put back into our jig, where again, we'll then reset our Z0 to the top surface of our material. Again, we don't need to alter our X0, Y0 as that's going to be exactly the same. Then we'll machine the next set of toolpaths, so it could look something like this. Once that's done, take the part out, rotate it again by 90 degrees, put it back into our blank, where we'll machine the next set of toolpaths after Z0ing off the top of our blank to cut the other third part out. And then finally, for the fourth side, you'll take this part out, rotate it 90 degrees, reset your Z0 off the top surface of the blank, where you'll then machine the fourth side. Now, when you are machining a four-sided part using the jig method like we are here, it's always good practice to have contact points on both ends of your blank to ensure that they are untouched. So every time you flip your material over on all four sides, or however many sides you are going to machine, there's always something that can fit into your jig. Because ultimately, when you are machining each side, you are machining material away. So it's always good to have contact points on both ends so we can ensure that we have our parts securely in place with every flip. To help us create some leverage for when we take our blanks out of the jig, we're going to create some extra pockets, going to be leverage pockets. That's just going to enable us to be able to get something like a chisel or a tool in there, where we can then slot it underneath our block or our blank and then help lever that up. Okay, so that's what those pockets are for there. Okay, so let's just talk a little bit more about the actual design itself. Okay, so obviously we've got 4 legs and each one of these legs is going to be the same. And the idea is that we're going to have this kind of fluted effect on all of the outside legs. Inside, we're going to have this brace that's going to slot into 4 of those legs just to give it extra support to ensure that it's sturdy and is safe. We're also going to have areas on the inside, so the inner parts are just going to be left blank. And so we're going to have something that looks like this. So we're going to have a leg that has a trio of flutes. We're going to have a groove using a ball nose tool that's going to go all the way around. We're going to have a profile that's going to eventually create us a tab to hold the part in place. We're going to have this fluted ramp that's going to create a nice tapered effect at the bottom of the leg. And then again, we're going to have a profile that again, all the way around is going to create a tab for us. So we're going to have 2 lots of these. So the fluted effect, so we're going to have one on one corner, one on another corner. And then on the inside, so for example, where this brace comes in and meets the inside, it's going to look something like this. So here we're going to have a pocket that's going to match the thickness of our brace and the width of the actual slot of the brace. We're not going to have the fluted trio here. However, again, we're going to have that groove. We're also going to have a profile along the top, a profile along the bottom, and the fluted ramp. And then on the inner side, we're not going to have anything fancy here. No fluted trio, no pocket. It's just going to have the profile, the groove, the fluted ramp, and then another profile. And so for when I come to machine this, I need to be aware of what sides match what part I need to machine. And so to visualize this, I kind of drew this diagram as if we're looking down on the table. These 3 lines represent these flutes. Okay, so outside, outside, so these are the outer corners here, outer corners there, and outer corners here. Our brace is going to go in the center here, where we need to have a pocket. So this rectangle represents this face that we need to machine. So we're going to have a pocket here, pocket there, and a pocket there. And then the inside, so we're talking about this side here, so not that side there, more so this side here, which we actually can't see, or this side here, is going to have just nothing. So it's going to be represented by these crosses here, and that's going to be this face here. So hopefully that all makes sense, and this is something that I must make sure that I'm following when I come to machine each face for each leg that we're machining. What I'll do is I'll just number each one of these blanks to ensure that we kind of match up that pattern. Okay, so let's just open up our file that we have so far. So this is the blanks and jig. So here you can see I've got a sheet where I drew out all of my blanks, and I have a sheet here where we've drew out our jig, and we're going to actually create our leg design on this sheet where we've also got the jig. That's just to ensure that we're always referencing from the same X0, Y0. So if we go to our Sheets tab, I'm just going to undraw the visibility of the blank sheet, and then we're going to just zoom in so we have better visibility of this sheet here. So you can see we've got the vectors there for our pocket, for the actual jig. We've also got the vectors here for our leverage pockets. If we go to our layers bar here, you can see we've got a new layer here, and then we're going to start creating the vectors for our design. So let's just rename layer 1. We're going to call this one Profile for Cut. And then what we're going to do is we're going to create our vectors that we're going to profile with. So we're just going to go into the drawing tab. I'm going to use the polyline tool. I'm going to snap to this point here and just come past a little bit past the edge of our part, right click just to accept that. To help us see this a little clearly, let's just go to our layers tab, and we're just going to undraw the visibility of the jig layer, and then we're going to take this, we're just going to nudge it down a little bit so it's past the bottom portion and the top portion, so that when we come to create our toolpath, we're going to get a nice clean cut all over the actual blank itself. Right then, so I want to create a copy of this 23 inches over to the right hand side. So we're going to right click and we're going to say copy, then we're going to right click again and we're going to say paste. Except with this one that's now selected, if we go to our drawing tab, we're going to use the move option. I'm going to move it relative to its current position in X by 23 inches. Go ahead and press apply and close out. So these vectors we're going to use to profile. So next up we're going to create another copy of this vector here. So we'll copy that and then we're going to paste it, Control V. Then I'm going to move that relative 2 inches in the x-axis. And what we're going to do is we're going to look at profiling on this vector with a ball nose tool just to create a nice groove, and that's going to go across all 4 sides, and that should just give it a little bit of decoration there. So let's actually move this to its own layer. So we're going to say move to layer, new layer, and we're going to call this one groove, and then we'll go ahead and press OK. Next up, we're going to create vectors that are going to represent our trio flute design. So we're going to go back into the polyline tool. Okay, so what we're going to do is we're just going to zoom in here, just going to snap to the very bottom there. We're just going to pull this out. I'm just going to kind of roughly, we just zoom in there, just roughly go around 12.2. That'll do. Press F just to fit that to our screen. Then what we're going to do is we're going to take that, we're going to create a array copy. Okay, so we're going to go up the y-axis. I want 3 of those, 1 in x. We're going to have a gap of around 0.45, for instance, and then we'll go ahead and press copy, close out, and then we're actually just going to group those. So press G on the keyboard to group them. And I'm just going to snap that to the center point of this line here, or at least let's make that to the center of our job. So press F9, and then what I'm going to do is I'm going to align it up to the right hand side of this line. So I'm going to hold down Shift, select that line here, and then we're going to use this option here to go on the outside edge. But then I'm going to back that off a little. So we're going to take that and then we're going to move it. We're going to move it relative in X by around 0.5, so around ½ an inch, and we'll go ahead and press apply, close out. Now you're probably thinking, where did you pull all of these numbers out from? And this is purely just for me to demonstrate to you guys how to draw those vectors. I actually drew this a little bit more organically originally, and so I'm just trying to follow as close as I was to my original file. Okay, so with those, we're going to right click and we're going to move that to a layer. I'm going to say new layer, and we're going to call this one Flute Trio. And then go ahead and press OK. Next up, we're going to create our vectors for our fluted ramp. So again, let's go back into our favorite tool, the polyline tool. Okay, and then we're just going to draw in a line here, somewhere kind of something like that. Then what we're going to do is we're going to take that, and then we're going to again use the array copy tool. So we're going to use the array copy tool. In this case, what I want to do is I want to have a very, very small gap between each one of kind of 0.05 in this case. And that's just to ensure that we create an overlap, because we are using an end mill to cut the ramp out, and obviously we're going to be creating a somewhat of a 3D shape, but purely from the fluting toolpath. So we need those vectors to be as close together as possible, and that tool is just going to constantly go over each one of those lines to create our ramp, and you'll see how we do that in the fluting toolpath shortly. Okay, so we're going to do that. Let's just set that to around 35 rows in Y. And then we're going to have a gap here of 0.05. And then we'll just go ahead and press copy. Okay, so you can see those copies have been made there. And then what I should have done is checked the option to group copies. So let's just undo that, check the group copies option, and then copy it, close out, and you'll see that it's created that there. And then what we'll do is we'll just move that down into our jobs. Somewhere around here we can see we actually have a few extra that we don't need, and so what we could do is we could just ungroup them by pressing U on the keyboard, go over here, just select those 2 that we don't need, and then just delete them using the delete key. And then what we can do is we can just shift and select all of the other vectors within our selection there, and then press G just to group them back again, and press F to fit that to our screen. And then as always, let's just move that to its own layer. So go move to layer, new layer, and this one we're going to call this one fluted ramp, and then we'll go ahead and press OK. Okay, so we now have all of the vectors that we need for 2 sides of our 4-sided leg. So now we can start to create some toolpaths. So let's switch over to the toolpaths tab. Okay, so you can see already we've got the jig and the leverage pockets toolpath in here, but we're going to go straight to looking at creating the toolpaths for the actual leg itself. We've already ran through the jig and the pockets in the introduction there. Okay then, so the first thing that we're going to do is we are going to go into the fluting toolpath. We're going to start by creating the trio flute. Okay, so in here we need to specify a start depth. We're going to set our start depth at 0. And it's worth noting here, if we go back to our material setup, you can see we've got our Z0 set at the top of the material block there. So, and you obviously want to ensure that everything is safe and appropriate for your own setup. Right then, so back into the fluting toolpath, we're going to set our start depth at 0, so right on the top of our block, and then we specify our flute depth. So this is the maximum depth that we want to come down to, in which case we're going to go with a very small 0.1. We're going to use this select option here, whereby we're going to choose a tool. In this case, I'm going to use a 1/4 inch ball nose, and we go ahead and select that. And then we're going to choose how we actually flute this, and I want to ramp in at the start and the end. And so looking at this graphic, it's going to do just that. We're going to ramp in at a specific length or a specific percentage, and then we're going to go down straight, and then we're going to ramp back up again. And so what we're going to do here is I'm going to specify a length, and we're going to go 0.1. So it's going to ramp across 0.1 to the flute depth of 0.1. It's going to go in straight all at 0.1, and then it's going to ramp back up to 0. We're going to do this in a smooth fashion, and then what we're going to do is we're going to use the selector option here, where we're going to have the software pull out the vectors for us based on some parameters that we set in here, which we can then take advantage of later on, and we'll come back to that later. So we're going to choose all open vectors, okay, and we're going to say every vector from the flute trio layer. You can see they're now selected, and I want you to associate that with this toolpath, and then we're going to call this one fluting trio, and then we'll go ahead and press calculate, and then we can preview that toolpath. So that's what that part would look like. Brilliant, love the effects that we've got there. Switch back to our 2D view, and then we'll just close out of that toolpath preview form. So next up, we're going to look at creating a simple profile toolpath using this vector here, whereby we're going to use a ball nose tool to create a very simple groove all around. So we'll go into the profile toolpath. We're going to set the start depth to 0, our cut depth to 0.1. We're going to use a 1/4 inch ball nose here, where we're going to machine on the actual vector itself. And then what we're going to do is we're going to go into our selector, choose all open vectors that is on the groove layer. We can see that's pulled up there. Then we're going to associate that with our toolpath. Go and press close, and then we're going to call this one profile groove, and then go ahead and press calculate, and then preview that. And you can see because our vector extends past the edge of our part, we've got a nice clean cut there. Wonderful, so let's just close out. We'll go back into our 2D view. So now we're going to take these vectors here, and we're going to create our fluted ramp. So we're going to go back into the fluting toolpath. We're going to set our start depth here at 0, and our flute depth, we're going to flute all the way down to 0.3. We're going to use a 1/4 inch end mill in this case, so we're going to use a 1/4 inch end mill there, select that. This time we're just going to ramp over the complete length, so we just want to ramp all the way down, where we're going to do that in a linear fashion. And then what we can do is then go ahead and use the selector option, and just to make sure that we have the software pull that up based on the rules that we set here. So all open vectors on the fluted ramp, so it's selected them. We're going to associate that with the toolpath, close out. We're going to give that a name. We're going to call this one fluted and then ramp, and then we'll go ahead and calculate that. If we just turn it on its side, we can see what it's going to do. So it's going to start here, and then it's going to run the complete length of the vector, where it's going to reach that depth of 0.3. And then we'll go ahead and preview that, and this is what it will look like. So you can see, because we've got all of those lines so close together, we're getting a real nice smooth surface there, where that tool is actually overlapping each one of those vectors. And then we can see we've got a nice tapered end there. And obviously we're going to be doing a taper on all 4 sides, so we should create this kind of pencil effect. Okay, so let's just close out there. I'm going to go back into our 2D view. Okay, so next up we're going to look at creating our profile toolpath to cut the ends out. And that's where we're essentially going to create a tab. Okay, so we're going to use this vector here, and this vector here. So ideally I want to machine on the left hand side of this vector here and the right hand side of this vector here. So before we go into the toolpath, let's just select both of those and then press N to go into node edit mode. So I can see we've got, because we just mirrored and copied this vector over to the end, they're actually the same, and so both start points are at the bottom. Now what I'm going to do is, to help myself, is I'm just going to change the start point of this vector here to be this top one here, and this will make more sense shortly, because the idea is I want to machine on the left hand side here and then on the left hand side here. And so when we're in the profile toolpath form, so when we choose which way we machine our vectors, when you're working with open vectors, a good top tip for you is to imagine you are stood on the green square, which is your start point, looking down, and you can see we've got an arrow on the actual vector itself, and that's telling you the direction. And so if we're stood on the arrow, we basically want to say we're going to machine inside left. Okay, so it's either inside or left, so we're going to go left and right here. So left, or do you want to machine on the right hand side? For this one we want to go left. For this one, again, imagine us stood here looking down, this side would be our left, so that's why I changed the start point there. Okay, so let's just right click just to come out of that. So cut depth here, we're going to go 0.5. We're going to use the select option here, whereby we're going to select a 1/4 inch end mill. We're going to select that. We want to go left here. We don't need to do anything like add in tabs, because we are essentially making those tabs already. We're going to go into the selector, all open vectors, profile for cut. You can see that they have been selected, and we want to associate that with the toolpath. And here we could just give this one a name, in which case we're just going to call this one profile cutout, and then we'll go ahead and press calculate. It's just going to warn us that we are working with open vectors. I know this, so I'm okay to do that. And then we could go ahead and preview that toolpath, and then this is one side complete, and so that's what our part will look like when we machine that first side. To help us visualise what two of these sides will look like machined, we should probably switch our job from a single-sided part to a two-sided part. Then what we can do is we can copy the vectors we need over to the other side. But before we do that, we're going to look at saving out the toolpaths as a toolpath template that we can re-import for quicker recalculation, which is why we use the automatic vector selection option and assign rules to associate with our toolpaths. So to do that, let's just close out of our preview. I'm just going to select these 4 toolpaths, and then what we're going to do is we're going to use this option here to save all visible toolpaths as a template. Okay, and in here we're just going to call this one table leg. Then we'll just go ahead and press save. Then what we're going to do is we're just going to switch over to our design tab, and then what we should do is just undraw those toolpaths. Okay, we're going to switch back over. Okay, so we're going to go into our set job tool. Okay, so it's worth noting that when we change this, we're actually going to apply this to all of our sheets, okay, which is okay. So we're going to turn all of those sheets into a double-sided job, set as the 0 on the top of both of those, X, Y, lower left, okay, and then we can choose which way we want to flip that. So we're going to flip it this way, so we're always flipping that way around, and then we could go ahead and press OK. Okay, so yeah, we can recalculate all of those toolpaths again. Obviously it's going to recalculate the toolpaths for everything that we've got there. Okay then, so let's just switch to our 2D view. Okay, so now what we're going to do is we're going to take all of those vectors and we're going to right click and say copy to the other side. Okay, and then we're just going to switch over to the other side here. And then we can start to think about the bottom side. Okay, so obviously we've already done this design here. So now we're going to look at creating the one with the pocket that has no flute. And so what we're going to do is we're going to ultimately create 2 parts that are two-sided, where we're going to have one where there's a flute, and on the other side the pocket, and then another sheet where we're going to have the fluted design, and opposite is going to be nothing, which is this one here. So it doesn't have the flute, it doesn't have the pocket either, it's just plain. So we'll work on the pocket there and we'll take a look at how we do that. Okay then, so we're going to look at creating the pocket slot. So we're going to go into the draw rectangle tool here. Going to create a square shape. Going to have a width of 3/4 of an inch and a height of 1 inch. I'm just going to somewhere click around there, close out. I'm going to take that shape. I'm actually going to center that. So somewhere like that looks okay. I might just want to nudge it along, and then we'll just click out to accept that there. So what we need to do is we need to remove the vectors that we don't need for this side. So we don't need these vectors, so we can delete that. And then for this one, we actually want to move that to its own layer. So we're going to say, move to layer, new layer. And we're going to call this one pocket for slot. And we'll go ahead and press OK. Okay, so in terms of the actual pocket itself, so the 3/4 of an inch by 1 inch, that is what I intend to have slot into this portion of the leg, which we'll come to shortly. I need to ensure I've got fillets in there. So here, 1 to 5 radius, because I'm going to cut this out using a 1/4 inch tool. Okay, so there we go. Close out, and we'll just press F to fit that to our screen. And then just zoom in there, it's because we've got the other sheet visible there. Okay then, so what we can do now is we can come over to the toolpaths tab. And then first what we can do is we can load in our toolpath templates. So let's load in our toolpath templates. We've got our table leg, open that. So would you like to apply this template to all sheets? No, I only want to apply it to this side, so I'm going to press no, and that will import those toolpaths for me. And we're just going to take that toolpath, so the fluting trio, because we're not going to use that on this side, we're just going to delete this. And because we've flipped the vectors over, I just want to ensure that our profiles are in the correct orientation. So if we go to node edit, yeah, we can see the start point is at the top there. So we're just going to position that to the bottom. So P there, and then over here, we're going to press P on the keyboard there. And then what we can do now is we can go ahead and we can look at creating our pocket for the slot. So we're going to go into the pocket toolpath. Okay, so here we're going to set our start depth at 0, our cut depth at 0.4. We're going to use a 1/4 inch end mill for this slot here, so we are using a smaller tool. We're going to use an offset strategy to cut that out. We're going to look at applying a pocket allowance as well. So we're going to put in a negative allowance of negative 0.001. So what that means is we're just going to overcut it ever so slightly, and that should hopefully give us a little bit of wiggle room to ensure that we can get the brace into those pockets, so it's not too tight, neither is it too loose for us to access that pocket. Okay, and then what we can do is we could go ahead into the selector. Say we want to select all closed vectors that are currently on the pocket for slot layer, and you can see it's pulled that vector up there. We want to associate that with the toolpath. We can go ahead and press close, and then we'll just give that a name, and we'll just call that one pocket slot, and then we'll go ahead and press calculate. And then what we can do is we could go ahead and preview that. So we could preview that toolpath like so. And then what we can do is we could just go ahead and preview all of the other toolpaths. So what we'll do is we'll just ensure that we have recalculated those. So let's just recalculate the visible toolpaths just to correct the profile direction that we changed earlier. And then what we can do is we can just preview those visible toolpaths also. Okay, and there we have it. So we've got our pockets, we've got the ramp, we've got the pocket for the slot, and then we've got the profile groove here. Right then, so next up what we can do is we can switch over to the bottom side. And then we can select these vectors, these toolpaths here. And again, use this option here to preview the visible toolpaths, and we can see how that looks against the other side. Okay, and there we have it. So we can see there that our tabs line up nicely, and you can see that we're just left with a little bit of material there that's is enough for us to safely keep that secure in place. You can see that the taper there, what that will look like, and obviously this is just on two sides, so we can only visualize two-sided parts in the software, and ultimately we will be machining on all four sides. And so essentially we're just going to do a rinse and repeat for the other two designs. So it'll be this fluted design plus a plain one. So let's just jump ahead now, and we're just going to go to File, Close. And then we'll go open an existing file. We're going to open the table legs. Open that, and you'll see the second design has been added to our project here. So we're just going to switch over to the Toolpaths tab, and then what we're going to do is we're just going to preview all of the sides for the second leg. So there we have it. So we've got the fluted design on the top. You can see everything lines up correctly, and then on the underside it's just plain. We've got that tapered effect over there along with the groove and the profiles. Okay, so obviously as well, because we can't visualize this in a four-sided part, obviously it's going to be tapering on these sides also from where we're machining and onto the other sides as well. So it's not quite what it will look like here, but we'll see the effect of that when we come to machine it. So that's pretty much it for the legs. So the crucial thing to remember is every time we put a blank in, we need to make sure that we reset our Z0 off the material surface, and we want to make sure we're doing the right design for the right side that we're machining. So let's go to the labs and we'll take a look at that. Okay, so we've got our oak secured down to our spoil board. We've got a long end mill in the machine there, so we're using a longer tool purely because of how thick the material is that we're working with, so you can get in there and cut it all out. We're going to cut our 4 blanks, and then once that's done we're going to take it out, and hopefully all 4 sides will be of the same thickness. So now that we've got all of our blanks removed from our material, we're now ready to move on to the jig, and the jig is where we're going to create the pocket that our blanks can slot into, and then we'll take them out to turn them around to slot back in. So we're using hardware and material. You don't want to use something like MDF because of the fibres. Every time you're taking a part in and out, you could loosen it, and then your accuracy level is going to go a bit down. So we're actually going to reset our X0, Y0 because I've took the material off of the bed. So we're going to put it back on, secure it down, reset all of our X, Y and Z, and then we'll go from there. The jig is cut, we've got our leverage pockets cut as well. So next up we're going to take our first blank and we're going to put it into our jig. Probably going to need a mallet to kind of bash it in there. And going back to the leverage pockets, having them there is going to help us to then release it when we need to take the block out to change sides. So we're going to do that. At this point, it's also important to remember that once you've got your block in the jig, we need to reset our Z0 to the top surface of our blank. Right, and so we've got our blank out. I've done the second side, so it's a little tricky getting it out this time. And that's probably due to the amount of friction that we've got from the jig. So we've made a little bit of adjustment to the jig itself. We've added in a few notches, and that should release some of that attention, but yet we're still going to have the hold everywhere else where we haven't cut a notch through. So that's still going to keep our part held in securely. So next up, we're going to machine side 3 now, and we'll just get on with that. So we've got our first leg, so it looks pretty good. So you can see here we've got 2 sides with the trio flute, all 4 sides have that tapered flute, so we've got this nice tapered effect at the bottom. We've got our tabs, got a nice little bit of a ridge in here just for decoration. And so that being our first one, we're going to rinse and repeat that now 3 more times on 3 different blanks. I'm going to crack on with that, and then we'll come back and then we'll take a look at how we do the actual tabletop. So we've got our 4 legs all machined now. It's looking pretty good. So now what we're going to do is we're going to jump back into the software, and we're going to take a look at the actual tabletop and see how it will all come together. So let's go and open an existing file. So we're going to open the tabletop side table. Just going to go into our sheets layer or sheets tab, and we're just going to switch off the visibility of these 3 sheets. I don't need to see them at the moment. I just want sole focus on this sheet. And we're just going to take a moment to kind of talk our way through the design here. So you can see I've drew in a square that represents the overall shape of the tabletop. And what we're looking at is the underside of the tabletop, which we're going to machine on the top side of our material. Then drew in another square that represents one of our legs. And then using a line through the centre of our square, I created a copy over to the right hand side, and then took both of those and copied them over to the bottom side, in which case I had another line that was in the centre of our square here, and that gave me all 4 parts that were equally spaced out in that square. Obviously I created the fillets for the pockets for our legs to ensure that we're cutting into those corners. And then what I did was, thinking about this from a bird's eye point of view, is I drew in this brace, and it's just a simple H shape. And the idea is that this brace is just going to give us extra support lower down in the legs to ensure that they're not wobbling, and we just have the extra rigidity. So just going to switch on the dimensions layer. So hopefully you'll remember that we set the width of our slot for the pocket on the table leg to be 1 inch, and then it was 0.75 high. And so that's why we've got a width here of 1 inch there. We've also making sure that we kind of extend that brace 0.4 into our legs as well, which again, when we created the cut depth for the pocket, we set that at 0.4. And so this just helps us kind of map out how all of that's going to come together. And then again, for the actual table leg itself, we can see that we've got a width dimension here of 1.61, which is our material thickness. So everything all matches up there. And I took that H and I basically separated it out, moved it over here to cut that out separately. Now we are cutting into that chunky material, so I'm going to be looking at skimming away a lot of this material to thin it down. We've also got vectors here that represent our dowel holes. So we're going to machine this in a two-sided operation, whereby we're going to use the asymmetrical dowel hole method to ensure that we get correct alignment when we flip our material over. And what this enables us to do is it enables us to machine these dowel positions into the top side of our material, and then we can copy these positions over to the bottom side of our job. And then what will happen then is we can take those locations, machine them into the spoil board, and then everything will just line up correctly. And because we've done this in an asymmetrical fashion, it just means that there's only one possible way that we could possibly line this up, and so we shouldn't get any errors there. It also opens up the opportunity for us to actually machine this in a separate operation, so we don't have to do it all in one go. We could cut this out tomorrow, next month, next year, because when we cut the other side, we'll be resetting our X0, Y0s, so we'll be starting as if we're starting a brand new job. And we'll come to that in a second. What I did was I essentially copied these vectors over to the other side. Okay, so I just took the outer profile and I also created an offset inside where I'm going to make use of this vector here that actually comes with your clip art. So if you go to your clip art tab, you've got these molding profiles. I use one of these in order for us to create a molding toolpath. So it's going to give me this profile that you can see there around the outside. And then again, I've just copied that H or that brace over along with those dowel positions. Right then, so let's just talk about the toolpaths then. So we'll switch over to the toolpaths tab. Okay, so first off, we've got a pocket clearance for thickness. So if we just tile our windows here, we're looking at this vector here, and you'll see that I've actually increased the allowance here to overcut that to ensure that I'm cutting past the corner there. Okay, and then if we just go ahead and preview that, we'll see that what that looks like. And again, this is purely just to thin this out. Same for the brace, except we're just doing this at a different thickness. And ideally what we want to do is we want to make sure that we create a total material depth for the brace of 0.75. And if you hold down Control whilst you're hovering over a part of your preview, you can see at the bottom there it says thickness 0.75, which is perfect. That's the exact thickness that I need in order for that brace to slot into my pockets on my legs. Okay, so that's that. Next up, we've got the pocket for the leg slots where each one of those legs is going to slot in. So if we preview that to see what that looks like, you can see that there. And then finally, we've got our dowels. Okay, so I've measured the diameter of the dowels that I have and then drew them as circles here. Created a pocket toolpath, preview that, and that's essentially what that looks like. And so the idea is, once we've cut all of these, is we take this material off of our spoil board, and then what we're going to do is we're just going to close out here, and then in reality the first thing that we're going to do is we're going to take the dowels of the bottom side now, and we're going to machine those directly into our spoil board. And then the idea is that once we've machined those into the spoil board, our top portion is going to line up accurately with our bottom part. And what this also means is it opens up the opportunity for us to machine the sides to at any point we want, because all we need to do is simply reset X0, Y0, and our first operation is to machine the dowel holes for the bottom side. And once we've got that, when we flip our material over, those dowels are going to line up with the dowel holes that we cut into the spoil board. And because they're set up in an asymmetrical fashion, it also means that there's only one possible way that we can actually line the two together, which means again that we don't run the risk of inaccuracies by flipping it in the wrong direction. Right then, so then what we need to do is we need to create our moulding toolpath. Okay, so I've got this vector here along with the moulding, and if we just double click to go in there, you can see that we've set the toolpath position to the very top surface there. We're using a 1/4 inch ball nose, 1/4 inch end mill, so we're using the end mill to clear it, the ball nose to actually create the nice curvature there, using the create sharp corners option along with a boundary offset. And then if we go ahead and preview this toolpath here, we can go ahead and see what that looks like. So there's that there, and then if we go ahead and create our swept profile with our ball nose, that's what that part will look like. Okay, then we've got a profile for our brace. Okay, so that's cutting this part out here, and if we go in there and preview that, can take a look at that. So you can see we've got tabs in there that's holding that all in place. You'll see that we've only cut so far down, and that's because obviously we cleared away the underside, so we only need to go so far down. But you can take a look at the actual file to see what we've got in there. And then finally we created the tabletop again, so just cutting around the outside there, and if we go ahead and preview that, we can take a look at that, and then that's what we are left with. And you can see the two sides line up perfectly, and that's that. Right then, so let's head back to the labs to cut this out. Okay, so we're done machining the top side. So we've got our dowel holes. Want to check your dowels fit in those holes. They do perfectly, so that's good. If they didn't, you need to tweak that until they do fit. So the next thing we're going to do is we're going to unscrew the board. We're going to take our material off. Then what we're going to do is we're going to take the toolpaths from the other side and we're going to start to load those in. And the first thing that we're going to do is we're going to look at resetting everything. So we're going to reset our X0, Y0, and then when we set that, the first toolpath we're going to run is the dowels for the other side of our part, and we're going to go straight into our spoil board, and that's going to give us our location so that we have accurate alignment when we come to flip our material over. And once we've flipped the material over, lined it up to our dowels, secure that in place, and then we're going to run the other toolpaths just to cut the other side of our tabletop. So there we have it, a combination of two-sided machining and four-sided machining to collectively create this side table that we made on the CNC. Really pleased with how this turned out. Now, if you fancy having a go at creating your own version, you can get the file for this as part of the purchasable pack that's available on the user group website. And if you have any questions, then please drop them in the comments below and I'll be sure to get back to them as soon as possible. So thank you for watching and happy making.